Hey guys, so today we'll be solving course schedule on LeetCode. It's part of the Blind 75 series. So let's get started. Let's look at the question. So here they're giving us a variable num courses, which indicates the number of courses that we should take. And all of these courses are labeled from 0 to num courses minus 1. We're given an array prerequisites where prerequisites of I is AI, BI. And this indicates that we should take the course BI before we can take AI. And what we should do is we should return true if we can finish all these courses. Otherwise, we should return false. Okay. Now let's consider the input that they're giving us, num courses, which number of courses from 0 to num courses minus 1, and an array prerequisites of the form AI, BI. So basically, they're indirectly just giving us the edges array over here. And this is the number of vertices, right? So you can use these two to form the adjacency list of the graph. So how are we representing this dependency is, so if we have AI, BI, then we know that we have to take the course BI before we can take the course AI. So if BI and AI are two vertices, then there is an edge from BI to AI. So this edge represents the dependency of prerequisite, right? So that BI is a prerequisite to AI. So that means that we have to do BI before we do AI. So that's it. So if you take these V and edges, then you can build an adjacency list. So now how do we know if we can do all the courses or not? If we take a simple example where we have two courses, 0 and 1, and there is an edge from 0 to 1. Can we take both the courses 0 and 1? Yeah. So first we do 1 and then we first we do course 0, then we do course 1. So we can take both of these courses. Then if we take an example where we have 3 courses and so yeah. So can we do all the 3 courses over here? Let's see if we can do course 0. We cannot do course 0 because we have to complete course 2 before we can do course 0. Can we do course 1? No, we'll need to complete course 0 before we can do course 1. Can we do 2? No, because we'll have to complete course 1 before we can do 2. So in case of a cycle, so you can notice over here that we cannot do any of the courses because you cannot form any order in which you can, do them without like failing the dependency, right? That they've given the prerequisite dependency. So what this problem eventually boils down to is that we have to detect if the graph that we're looking at has a cycle or not. So how do we do that, right? So it's just simple. First of all, we can note down all of their in degrees. So the in degree of these both is 0, 5 and 4 is 0. In degree of 2 is 1 because it's an edge from 5 to 2. In degree of 0 is 2. In degree of 1 is again 2 because it's edge from 4 to 1 and 3 to 1. And in degree of 3 is 1. So we can do a course or visit a particular vertex if its in degree is 0, right? So we can visit 5 and we can visit 4. We cannot do the course 2 because we've not completed 5 yet. But if we do 5, then we can indicate that we've done 5 to its neighbors by reducing their in degree. So that this means that we're just deleting this edge, right? So now after doing 5, we update the in degree of its neighbors. So 2 will be, in degree of 2 will be 0, in degree of 0 will be 1. Now, so we can maintain an ordering here. We're done with 5, right? Now we can do 4 or we can do 2 because both of their in degrees is 0. So if I choose to do 4, then I should update the neighbors of 4, which are 0 and 1, and reduce their in degree by 1. So basically we're deleting these edges, right? So here, the in degree of 0 will become 0, in degree of 1 will become 1. Now we can do either 0 or 2. If I choose to do 0, then I don't need to update any of its neighbors because 0 does not have any neighbors. Then I do 2. 2 has neighbor 3 and I update its in degree. Now I can also do 3. So I do that, but I cannot do 1 because 1 still has in degree 1, right? Now I update the in degree of 1 and I can do 1. So finally, you can see that we are able to do all of the 6 courses that are there in this particular graph. So this is it. If you understood this, then we can solve the algorithm. The algorithm is basically we're starting with the vertices whose in degree is 0. And then we're updating for every vertex. If we're exploring it, what do we mean by exploring it is we're updating the in degrees of its vertices, of its neighbors, of its neighbors. So once we update these indices, we again search if we can find any vertex with 0 in degree and then explore it next. So let's look at the code. Here I'm initializing the in degree to 0 of all the vertices, which is just the number of courses in this case. And I'm using a function called makeAdj, which is taking the number of courses, the prerequisites array, and the in degree. And it's returning an adjacency list of the graph and updating the in degree of everything. So this is that's what this line is about. And I'm using VFS over here. So I'm initializing a queue and a visited array. Here in this, I'm visited hash map, which I'm calling it done to indicate that I'm done with a particular course, right? So now in the beginning, I'm looking for those courses or vertices whose in degree is 0. If it is 0, then I'm appending them to the queue, and I'm initializing the done map, all of them to false, right? I'm having a count variable, which I'm calling it courses. And I'm initializing that to 0. And until the queue is not empty, I'm popping out whatever is the first element of the queue. So all the elements in the queue are the courses, which we can currently do, right? That means their in degree is 0. So once I pop it out, I'm also increasing the courses variable by 1, because it means we're done with this course, right? And I'm going through its neighbors and updating their in degrees. Here I'm checking if we cannot append all of the neighbors to the queue to explore, because we can only explore those vertices whose in degree is 0. So I'm having that in the condition, and I'm also making sure that I've not done this course previously. Here I'm appending them to the queue and marking them that I've visited them, right? So the return condition is if the number of courses, the count variable, will be equal to num courses, then that means that there is no cycle and that we can complete all of the courses. Otherwise, if there is a cycle, then we cannot complete all the courses and it returns false. So that's it. This is how we solve the course schedule problem. I hope you understood my explanation. Thanks for watching.